Okay, hello again and welcome my students to again another session with Mr. D's math class. This time this is the last piece of our section on 4.2 linear relations, and this is part 4, and this is going to be talking about graphs or solid line graphs. You know, when you connect the dots on a plot, solid lines versus dotted lines, or sometimes called broken line graphs. Okay, but in other words, I'm going to share with you what some of these information. So if you have a solid line graph, usually the information that they're graphing is called indiscreet. Okay, and I'll explain what that means later. And then the dotted lines, usually when you graph that, they're usually called discrete data. Okay, so let's start with an example of a solid line or indiscrete data first. Okay, so this is your first graph. So this is going to be an example, let's say, of a solid line or indiscrete. Okay, so first of all, what I'm going to do is I'm going to make a graph, very simple, very quickly. Make a graph here. Okay, so let's say this is an example of boiling water. Okay, so it's a time in seconds versus temperature in degrees Celsius, let's say. Okay. And we're gonna keep this simple, okay? So it doesn't have to be super accurate. What I'm really trying to demonstrate here is what it means to have a solid line versus dotted line graph. So it doesn't have to be super accurate, but I am going to try to make it neat. Okay, so let's do this quickly. So 10, 20 degrees, 30 degrees, 40 degrees, 50 degrees. And as you know, when you're boiling water, as time goes on, it does get hotter. That's the natural way of physics. Okay? So let's say I do have this kind of plot. Okay? And again, it's a very simplified, by no means is this super accurate to actual boiling water. It's a very simplified graph. But what I'm trying to get to here is, can I actually, you know, connect these dots or these points, these plots, with a solid line running through them? Well, in this case, yes, I can. Okay, and the reason for that is because these are called indiscrete data. Okay, so indiscrete, well, this is IN here, in case you can't see it. Indiscrete data means there are in-betweens allowed. Okay, or allowed, or even possible, actually, because as you know, when you're measuring time, sure, I have in 10 seconds here, for example, the water is 10 degrees Celsius. But as far as time and temperature, there are in between 0 and 10 seconds. There's a 5 second, there's a 6.5 seconds. And the same with temperature. From 0 to 10 degrees, I'm pretty sure there is a 5 degrees, and there's a 7.5 degrees. So there are actually an infinite amount of plots here. It's just these are the ones that I, use to plot this graph. But anywhere along this graph, there really is in between allowed, and that's what indiscrete data means. Okay, that there are actually data in between here. Okay, in contrast, okay, in the second graph that I'm about to do, we're going to demonstrate to you what discrete data is, and you can probably already guess that this is actually quite the opposite of the first one. Okay, so in this example, let's try to imagine, let's say, you're buying game discs for your Xbox 360 or Xbox One, okay, and So here we'll put the number of games you buy or have bought in the past, or whatever, your collection. And you know, maybe you started off with 1 game, you bought a second game, 3 games, 4 games, 5. Okay, and let's say on average, and I'm simplifying this graph, on average each disc that you bought is about, let's say, I don't know, $40. 80. So I'm going up by $40 at a time here, 120, and finally, you know, 160. Okay, and so this is cost in dollars. And these are the number of games you bought. Okay. So you bought 1 game, let's say that costs $40. You bought 2 games, that will cost $80. Again, I'm going by, you know, this imaginary assumption that each game is $40, let's say. What I want to try to illustrate here is not the number of games, not the cost of the games, but the fact that there is no way that you can buy 1.5 games or half a game or 2.5 games, and nor can you most of the time negotiate, oh, I can only buy 1.5 games, so I will pay you $50, which is, you know, or $60, which is halfway between 40 and 80. So in this case, this is called discrete data, and when I plot this, or when I draw a line, these data points, it has to be a broken line or a dotted line graph, because these are called discrete data, meaning there are no in-betweens allowed here. And it really sometimes depends on, you know, the reality of the graph, okay, and the logic to it. But in most times, if you're really not sure if a data table is discrete or indiscrete, it's automatically assumed that it's discrete data and that there is no in-betweens allowed. There are no in-betweens allowed. Okay? And I hope this makes sense, because again, like when you're buying games, nobody comes to a store and say, you know what, I need you to cut that CD in half because I can only afford half of it. Is that okay? No, because even then it wouldn't make sense, because it'll never work. Okay? So I hope this clarifies for you at least what discrete data is, and what broken line graphs mean when you use it, and what indiscrete data is and when you can use it. Okay? In discrete data, there are naturally in-betweens allowed, such as temperature and time, or time and distance, whereas discrete data, there shouldn't be any in-betweens allowed, or you're not allowed any in-betweens, and so this is the only data that you're allowed, and it must be dotted lines or broken lines. Okay? Thanks so much for paying attention, and goodbye for now, and I hope this helps.